So I guess we'll start getting going. I don't know if anybody else will show up or not. I'm hoping. I mean, it's not like you got to drive to class, right? So welcome everybody. Hopefully everybody's doing okay. Family members, everything like that. Hopefully you're all staying at home and doing nothing by yourself. As I mentioned, my one big dilemma I've been going through is my roommate not taking it too seriously. So like a few days ago he had a friend over, and then his girlfriend came over, and then later they were making food and another neighbor came over. I had to have like a serious talk with him. I'm like, listen, I don't know if you know how bad this is. So trying to get him in my boat of trying to just be on lockdown for a couple months, it really sucks. But the way I see it though is maybe a technique that you guys could also be thinking about, because I don't think this has been talked about. Say if you completely go on lockdown with somebody, or you like I go on lockdown, your grandma goes in lockdown, right? For 2 weeks, you both don't get sick, you both haven't come into contact with anybody else, you both know that you don't have it. So in that case, then you could start hanging out because you both know you don't have it. I mean, the go-to has been just like, oh, you can't go anywhere, you can't do anything, which technically is true now in New York. You're not supposed to be. I mean, people still drive. So I think as long as people are going through that 2-week thing and they're really strictly making sure, like, I haven't seen anybody, or, if you're going to go visit your grandma, you don't want to be sick. So have you seen anybody else, right? And whoever that person you've seen, has that person seen anybody else? So it's like you have to be really particular, I think, if you're going to do your part. But what I'm getting at is I don't think we technically have to strictly be isolated alone for 9 months or something crazy. I think it's just really if we do a firm isolation with certain people, and we know that those people haven't encountered any new people, you kind of start the timer of 14 days from the last encounter kind of thing. I don't know, something I'd throw out there. Anyway, so yeah, welcome to our new classroom structure, apparently. It seemed like it worked okay my last class. I will note that there is a bit of lag between my screen, like my real time, and getting over to you guys, which I kind of see here because this is a separate computer. So yeah, I mean, giving you guys like the context, I just have a Mac Mini with a TV screen. So that one doesn't have a camera on it. So what I personally am going to be trying to do is leave just my screen up here for relating my whole screen to your guys' screen and doing recording on that computer. And then on this MacBook, I'm going to be leaving open my my chat window, and I can kind of see some of you guys if you guys end up having like cameras on, but I can't see everybody at once anyway. So primarily I'm just going to be focusing on trying to make sure I pay attention to the chat window, which for some reason now is not. Oh, there it is. Okay. So yeah, at the bottom of your screen, you guys should all see these bubbles. That's where you turn on your microphone if you wanted to say something. I think for the most part, you probably can just leave it off so that, if you have to talk to people or whatever, you have music playing, it's not going to be distracting for everybody. But and I can mute people too, like if they leave and something, they forgot they had music on or whatever. However, if we do get to the point, like I think next class, the goal is to kind of try to talk about each other's storyboards, like sketches, their concepts. We're going to see how that goes. And during those, I think it's more of like everybody has their mic on, but we all just kind of take turns talking. Also, we could text things in the chat window if you want. So yeah, at the bottom, you should also see a little text bubble. Primarily, you probably should just leave that open. Because not only will I be looking at it, but if other people say things, it might be pertinent to the conversation. You know, maybe somebody wants to say something, but they don't want to use their mic, they're shy or whatever. I don't know. We could all, you know, keep track of the text window. And I'll note that my reactions to it might be delayed because it's literally on a separate screen. But I'm just... we're all trying to do our best, I guess, to, you know, work through this new experience. So, that being said, we're going to just start diving into class today. Let's get back down here. So today I'm going to be covering the best I can, relating a lecture to you guys with processing. And then we're going to start our first like in processing exercise. So it will be a little tricky for me, I guess, to we're going to see how this goes. I don't know. As soon as I heard we're going to distance learning, I got really I don't want to say bummed out, but kind of started getting a lot of anxiety because, like, how do you teach coding remotely? Because if you have a problem on your screen, it's going to be different than everybody else's problem on their screens, which is why I chose this platform, because in theory, we should be able to all share our own screens with one another. I don't know how that's going to go yet. We won't have to worry about that today. We'll start getting into that when we have problems. Well, actually, we might have to get into that today. Yeah, if you guys have a problem with your code, you know, we'll have to see if we can share a screen. What was I going to say? I kind of rambled there for a second. Welcome, whoever just joined. Lecture processing. Does anybody here not have processing installed? Everybody should have that installed by now. So if you don't, I'd probably make sure you go out and grab that. I'm going to just start trying to do this lecture here. I'm going to do my best to have just the lecture up on screen and have my kind of presenter notes on my phone. I've only kind of went through this once. It seems to be okay. It'd be a little choppy. I don't have a third computer that I can put on my desk here, so. Okay. Up and running here. I'm assuming everybody can hear me. Everybody's doing well with starting off here. So yeah, and again, just like any other lecture, it might be good if you guys have, you know, your sketchbook or just a sheet of paper, whatever, out for any kind of notes that that you might want to take. With coding, it'll just be more along the lines practice of going through. But some of the ways that I try to contextualize what the different coding elements are might be helpful to take a quick note on if that's how you learn. Just to give you a background of my coding experience, I did like very minimal stuff in high school. Like community college, I did very light stuff, but then I haven't used it until grad school, and until I started coding in processing here, as well as Arduino. So I don't have like a computer science background, and that's not what I try to relate to you guys. So if you guys have computer science backgrounds, um, it'll be like um, me probing you a little bit on different components, or classmates might probe you a little bit. So it'll be good to know, if anybody does have a higher level of knowledge. But basically, what I try to do is give you the structure of how I've been using programming and processing, so that you can then take that and regurgitate that and recycle it into your own project. So realistically, it's not going to be too complicated, but it will be a little weird right now, probably, if you haven't coded before, in terms of what things are making sense, and what things are a little confusing. So I guess just if you do have a question, obviously, you turn on your microphone real quick and you can ask it while I'm going through. Otherwise, I might not see a question in the chat right now, because I'm already doing two different screens. So give me one moment. Yeah, so processing itself is going to be a program, as you kind of probably already seen in that 1 hour of coding last week or 2 weeks ago now, is that it really is a nice tool from transitioning into not coding to coding, because you get a very, like, this cause and effect. You change something and you get to play it back immediately. It seems like it might be like most programs you might encounter are kind of like that nowadays. A little bit quicker to give you that preview. But back when I started learning coding, it was very clunky. So it is really nice to be able to have something you can just visualize from your own code. And obviously that book, I don't know if this link still works. Let's see. It just gives you the processing website. So that's the big thing to be focusing on, like why we're using processing, is just the being able to have this cause and effect kind of premise of working. We will be doing primarily vector-based drawing, and we haven't gone over vectors yet. Usually we've done, my class has usually done the Illustrator project first. As I mentioned, this year I wanted to have processing first, so that by the time the end of the semester is here, you guys have an interactive project that you can display for the end of semester show for DMS. And great, I don't think that's probably going to happen now, so great planning on my part, I guess, for no reason. But so you obviously still can use raster images. The vector stuff is going to be more along the lines of coding shapes on screen, which you already did a little bit with, like circles, lines, that sort of thing, 2 weeks ago. We also be able to change colors, use like camera, mouse, keyboard input. I won't really get into object-oriented programming with you guys as tutorials or anything. I kind of dove into it deeper last semester with P5.js. So I do have a pretty decent kind of structure of working with object-oriented programming. So the only thing I want to make sure you guys comprehend is, if anybody was planning on doing a game where there's a lot of like objects colliding, stuff like that, that gets into object-oriented programming, and it's pretty complicated if you've never coded before. I have had students that haven't coded before, and they got some stuff object-oriented programming coded out by the end of the semester or the end of this project. But it's hard because we're also doing this remotely now, right? I can't sit there in person and help you on your computer. So if you're new to coding, what we'll probably want to be thinking about moving away from that that mentality. But again, we'll be kind of reviewing project concepts and stuff on Wednesday, so we can make sure we're covering those concerns at that time. Again, what you've already figured out is we're just basing this all on a grid system, and I wonder if I should make my cursor larger. I guess you probably all can see this fine if you're full screen. So yeah, the only goofy thing that I've always been frustrated about is the coordinates is kind of like backwards of what you would think. You know, I would think this would be like a top right quadrant of like a grid, but it's really like the bottom right. So if we're moving over, we're gaining in the x-axis. If we're moving down, we're gaining in the y, which is like, won't you be subtracting in the y? But no, we're adding. So moving forward, this is starting getting into the coding parameters here, and kind of going to jump back and forth between my notes, so apologies for being a little stuttery. It's kind of weird delivering this. The only thing that you want to be really focusing on, and if you're taking notes, this is a good point to be putting down, I guess, is these so first of all, our code runs from top to bottom, right? I think that was probably covered in the lecture 2 weeks ago, or the exercise. That will start to gain importance as we start to unfold these things, primarily in terms of layering, right? Whatever you have on more so down the list will be like refreshing on top of whatever was drawn previously. So you can kind of think of that as layering like we would in Photoshop. Like if we had two rectangles and they're overlapping, the one on top would be the one on the bottom, right? So the way this code is set up here are we have these voids, and you can see these are more primary elements of code, and ways that you can tell that that is true is that they have a different color in processing, right? They are tabbed, or they're kind of flush to the left of the screen here, right? So we have our line numbers 1, 2, 3, 4 all the way down the left-hand side. When you guys open up processing later, the line numbers might not be on there by default, but you could just go to like the help menu at the top and search for line numbers, and you could toggle them on. I think it's on by default. So the way this works is we have these different void setups, these void conditional kind of parameters, and they basically are you can think of them as different sections of code, right? The void setup itself is kind of loading in components that you're going to be using. So for instance here, our size is literally the size of the canvas. It's 500 pixels wide by 400 pixels tall. So as we go along, another thing, if you get lost on different components, I'll be able to show you how to find references for, what this stuff means, and to troubleshoot it on your own. Point isn't really something that I would be putting here, but I don't know why I have it in this example. Background is another thing you would probably load in right when this thing starts, right? When we hit play to run the program, you might want a background to be on there by default. So right there, you could have it pop up, and this would be just a color, looks like, right? 3 different numbers is a color. And how do we know that? Well, as we go along and we do more of these examples of different elements of code, you'll be able to save those files, those processing files, and you're like, oh, what was that code that I needed to type in to get a background? You literally just open a file you previously already had, and that file will be acted as like a note, right? All of a sudden you have access to all these notes you can copy and paste from. So that's why this coding shouldn't be too dramatic for you. You don't have to like memorize every single line. It'll come naturally as you use it more. The big points here are kind of getting into the structure, making sure you understand the basic structure going in. And that's what I'm hoping you guys take out of this this lecture, but also the tutorial we're going to do. So we always kind of start off these sections of code with a void setup and a void draw. That's just for our processing needs. The setup is going to be loading things, like we obviously need to have a canvas size, otherwise we won't see anything, right? So if we don't have a setup, we're not going to see anything. So I always need a void setup with some kind of information in there. And then void draw is going to be the contents that we're going to be playing on a loop. So from top to bottom, starting like this line 8, it's going to read, oh, stroke is going to be this color, the fill is going to be this color, and those two colors are going to apply to this rectangle, and the rectangle is drawn at this coordinates, right? So once this program reads line 8 and then line 9 and then line 10, it just starts over from the top and it goes over again. 8, 9, 10, 8, 9, 10. And by default, I believe it's, I can't remember, I think it's 60 or 30 frames or refreshes a second. The program just executes everything in draw like 30 times a second. Right now, if we played this, all we would see is maybe this point, whatever this point is, but really we're just going to see a background color with a rectangle in the middle. And that's it. It won't be changing. Even though the draw is continuously running in the background, it is running, but we're only seeing that static object because the coordinates for the object are static. They're not moving. They're literally just plain numbers. Those numbers aren't changing as of right now. We're going to be talking about how to make them change, which you guys probably did a little bit last week, a couple weeks ago. But yeah, we'll get into that. So that's the primary two things you need to be taking away from this slide, is that we always need a setup and a void draw. Setup executes things one time. Things in draw are running on a constant loop nonstop until you close the program, right? There will be other kind of void components that we can add later on, but we'll get to that. We'll get to that, I think, like next week. Okay. Oh, and I didn't even realize that I have supplementary notes here, which is everything that I already talked about. But oh, so this is the one thing too. Functions are the technical term for all these kind of different components that you see that are also a different color. Like stroke is a different color, fill is a different, right? There are these blue colors. These functions are already like pre-programmed. The computer, like this program, already knows what to do when you type that, right? That's basically all a function is really meaning. So when we're calling a function, we're realistically just like telling the program to do something for us. These void components, they're for organizing our data, right? It's kind of like you could think of them as different containers. Whereas these functions are the actual components that we are able to tell the computer what to be doing. And most always they'll end with a semicolon. So you'll see most of all those, that's basically just saying, okay, stroke, do something and end that statement. Then you can go on to the next one, on the next line. And that's about all there is to that. These different primitives, again, all of this stuff, I didn't mention actually, all of this stuff is right on the processing website. They have a whole page, like top to bottom, with like all the basic stuff that you could possibly think of using in processing. And so if you're stuck on something, or you are trying to find a new interesting thing to play around with, they have example pages, but they also just have like, information on all of these functions, like these point, line, triangle, how to use color. They'll have like a whole website page dedicated to color and how to use color. So these aren't things necessarily to be like writing down and memorize, because they're really easy to go out and find reference for. Again, most of this lecture is going to be like main takeaways of the structure and how things are working, which this all should be making a lot of sense as long as you guys read that like that first chapter or so in the processing book, the handbook. So again, different fills, strokes, this kind of stuff is also going to be listed right on the website, right in our examples that we're going to be doing as well in class. You'll have access to that. Where are we at? So variables, this is the next component that really starts to transform our code. So without variables, we'd pretty much just basically be static images. Variables themselves, they allow you to inject, like to update a component of code. So rather than just having a square in one spot or a circle in one spot, you guys were able to like have them move around. Well, instead of having it say, a circle at 50x and 50y as a starting origin, you could have them as an integer, and that integer could update in values. So what I mean by that is an integer, literally, I guess I shouldn't have used the container option earlier. An integer, literally, you could think of as like a container, right? Like as a cup. And whatever value that you tell that integer to be will then update in all the places that the name of that integer is used. I think I have an example of this, but we're basically going to be using integers. Some of you might get into using floating numbers or booleans. A boolean you could think of as like a gate. It turns something on or off. It's like a switch. You want something on or off. I personally don't like booleans. I just use integers and literally just have like a 0 is off, a 1 is on. So I don't even use booleans myself, but they can be really simple. And floating numbers, literally just decimals, right? Like not 1, 2, 3, 4, but like point, some kind of not whole number. So this is the example that I often give. So you guys start to think about what an integer actually, like a variable actually does. So if you all think of like what is a perfect score on like a test, right? What is a perfect score as like a percentage? We all are going to know that it's 100. And so you could have a integer as a variable. You could say integer perfect score, and you could have that perfect score equal to 100. So anywhere in your program, you could have a value that you want to be 100, and you call that location perfect score. And then later, though, say if you wanted that perfect score to be changed to an 80, you could update perfect score now equals 80, and anywhere that you've had the name perfect score written into your code, it'll update that value to the new value. So it's kind of like this placeholder kind of container mentality. And again, it kind of makes sense if I'm talking about it, I hope, but it also is a little confusing until you start to use it. I guess the goal here is to, especially because we're not face to face, if you guys have questions on this kind of stuff, the goal of each class, like when we're doing these tutorials, is to make sure you really grasp everything that's going on, and not that something's confusing. Because as soon as something's confusing and you ignore it, that's where I start to see students have problems moving forward. So it's a good idea to make sure you're comprehending the different bits as we go. So again, if you guys have questions as I go here right now, you can chime in. So here's a pretty terrible example that I wrote several years ago. Integer x is just integer x. What is x? It's something that I named. X is something that I made up and I put there. Just like integer p, I also put there. Except this p, I set a value to 1. So anywhere in the program, if I say, if I want to use a custom color and I want the red color to be the value of p, that red color is going to be 1, right? So basically this is the breakdown. Anywhere that you can possibly use a number, for the most part, in processing, you can also use this integer variable. You just have to define it. So this is just the syntax for defining it. You tell the program, hey, I'm going to make an integer, int. It pops up in this orange color because the program knows that what an integer is going, what it does. You specify what the integer is named, and then you can optionally give it a starting value if you want. So right here, what's the value of emergency? If this p is 1, poop is 2, emergency has the value of 3, right? It's basic math as well. So you could be using basic math in your favor as we go along with these projects as well. And trying to keep track of where I am in my notes here. This is kind of covering the different cases that you could be using, so uppercase, lowercase. This isn't super crucial, but it is fairly good to maintain the same structure. So as you guys go, if we're all using the same way about using code, it'll be helpful for me to help you out, for other people in the future to kind of understand what you're doing. So as you can see here, we have something called integer player 1 equals 1. Well, it's kind of weird because it's all, when you're defining an integer, you can't have spaces in there. It just has to be all in one segment. So it's kind of weird that we have two words combined right there, right? So instead of doing that, the kind of trend that has been developed in coding is to always have the first word, if you have multiple words, the first word is lowercase, and then every consecutive word after that will have an uppercase first starting letter. So that's the way you can kind of be, as you're naming new things, right? Like, oh, I need an integer, for my character. Character 1, you'd have an uppercase 0 or O. Moving forward, my phone keeps going to sleep. So this is something that I think we might be looking at today, but more so next Monday when we dive into kind of like our second tutorial. The second tutorial is really going to be giving you guys most of you more of a firm basis for reference for building out a program. But this is also a core component, so this is why I'm covering it right now. Again, we have this void condition, just as we did before. Just kind of talking about void again. We always have these, any void condition that we have is always going to have these parentheses after the name, and then it's going to have a bracket, a starting bracket, and it's going to end with an ending bracket. So what ends up happening a lot of times that a lot of people get confused about is what brackets are for what, right? Like, why do we have this bracket here with another bracket here? Do we need both? Do we, what happens if we don't have one? If you don't have everything in place, when you go to run the program, processing will give you an error, and it'll usually tell you where the error is. So that being said, here, normally what I would like to do, which I always recommend to you guys, and I'll keep saying this as we do tutorials, anywhere that you have a void, wherever a void starts, you're able to like click right there, which I can't do right now, but you would be able to click right next to, to have your cursor right next to that bracket, and the program will highlight the closing bracket. Same thing with any closing bracket. If you click next to it, it'll show you where the starting bracket is. So instead of like doing that every time you need to figure out where brackets are supposed, what a bracket's for, I always just like to put a comment in after certain brackets, especially like void conditions here. So right here on line 18, after this bracket, on my own code, and I'm hoping you all do this as well, is you'd put a couple of slashes for a comment, which I'll cover in a moment, how to add comments. But you literally will just say ends void draw, right? You have a starting bracket up top, and that particular one that you're commenting on would be ending it. So that's just to reiterate good workflows, I guess. So this particular slide, though, is on conditionals. The primary one that you guys will be using, you could get away with this entire project of just using if conditions. Some of you might use an else. I'll talk about else if you need it. If conditions, literally all they do is start out by saying if, right? And once you start to add that parenthesis there, or that parenthesis there, it'll turn green. Again, letting you know that, oh, this is a component of the program. It knows what it's doing. And then I type in whatever I want, and I'm checking that against something. So the whole premise of a condition is literally that you're checking a condition if it's met or if it's not met. Okay? So in this case, and I'll show you another slide of like why or what all of these could mean, like two equal signs. In this instance, we're asking the program if emergency, which is an integer value that we just discussed in the previous slide, and as we know, integer is the value of 3 because p and poop was equal to 3. So if emergency is two equal signs, you can kind of read that as is. If emergency is 3, do something. And the things that you would do would be between the brackets. Right? So we have a starting bracket and an ending bracket for that if condition. So if emergency is 3, then we're doing some kind of code. We're telling the program to update something. And for this example, x equals x plus 1 doesn't really have any relevancy, so I wouldn't worry about like what that means. It's just you're able to put a strand of code in there that updates something. So I could then say if emergency is 3, then I could say right here, I could change it to say emergency equals 0. Well, then if emergency equals 0, the next time draw goes down and reads this if condition, emergency will no longer be 3, so you're kind of like turning a switch off. So it just depends on how you want to be, what components you're wanting to utilize. Not continuing here. So this is another screen for expressions. So just like we just seen, there's two equal signs. You could be asking, equivalent to or if. I like to think of it as if. If emergency is, so is. I guess it's whatever way you want to think about it. We're basically checking values with that, one against another. However, we could also be doing other things like, is 72 greater than 35? So which I don't know, that's not a good example, I guess. But so anywhere we're doing an if conditional statement, we have a variety of different parameters that we can, these rational expressions that we could be using. Continuing onward. These logical operators are probably confusing right now. I will revisit these next Monday. So essentially what you're able to do is say, if this had an if right here, and you're saying if x is less than 20, that could be one conditional statement, right? That you would then put a bracket and a closing bracket and you do something. However, you're able to actually put these pipes if you wanted to say or x is greater than 80. So what this would mean is for this example, if x is greater, if you think of x as mouse x, right? If your mouse x is less than 20, so over on the left side of a canvas, maybe having something activated with this if condition. But after 20, before you hit 80, somewhere in this area, maybe there's a dead zone and nothing's happening. Or if you go past 80 again, your mouse x would be higher than 80. So these operators allow you to kind of have make your code more concise. So rather than having if x is less than 20 and do something, and then have another if condition that's saying if x is greater than 80, you could have them both on one line, essentially. So again, we'll have another visual example on next week. We're not going to need to use this today. There are other kind of ways to move objects, not only just moving the numbers across the screen, but we can rotate things, we can scale things, we can translate. Some of these get a little finicky, but they are possible, and they do actually make some pretty fun effects. Again, we're just dealing with RGB color in here. You can use other stuff like hex, but I want everybody just using RGB so that it's synonymous. Yep, it's just, again, 256 different colors, including 0. It's 0 to 255. If you were to use just one color in an argument, you would get black, like a grayscale. If you use 3 colors, that gives you RGB. If you add a 4th color to an argument, that's when you start to be able to use opacity to make something transparent. And that actually works with images as well. So you don't have to, if you brought an image and you're like, oh, you know what? I wish this character was somewhat transparent, or, this background cloud image was transparent. You could also use transparency, like this opacity number on an image as well. So that's something to keep in mind. Mouse data is the primary thing we're going to be starting with, plus pressing a mouse button, keyboard data. Some people like to use this as well instead of just mouse, right? Because we have this other tool that inputs data right in front of us. We might as well access that if we want. Coded keys, not going to worry about that. So yep, these are kind of just reiterating those different types of events. And again, these all don't have to be memorized. If you're like, wait, I want to be able to click on this object, and not for it to automatically pop up in another spot, but as you press and hold it, then you can drag it. If you let go of it, you're not, it won't follow your mouse. It only follows, maybe an image will only follow your mouse when you click and drag. So then there's a function called mouse drag for that, right? Not something that you have to memorize. When you realize oh, you know what, I need to drag something, you just go to the reference website. You literally do a command F on the website to find in the website on the web browser, and you search for mouse, and it'll give you all of the same stuff with examples. So these are just more or less letting you know that we have the ability to have a variety of different ways that we're utilizing code. This is kind of just reiterating on draw. Yep, it is 60 frames, okay. For some reason, it doesn't seem like it always runs like that, but draw is like reading every single line down that you have there 60 times a second. So it's really fast, right? It's like goes down through and reads everything and starts at the top again. Frame rate, if you use this code syntax, you would be able to slow down the rate at which draw is refreshing, like is reading itself or looping. No loop at all would just stop draw. Like why would you do that, I guess, but redraw would be something that you guys could utilize to like, start over from the beginning potentially. So lots of different things to be considering. So the cursor itself, right? Like when you guys see my cursor on the screen, your cursor on your own computer, we just see this standard black kind of pointer, right? A cursor. Well, that doesn't have to be. We could actually turn it off if you want. So maybe you have a section of your code or a scene where you don't want the mouse to be activated. Maybe it's distracting to have it, like, oh, the user can scribble like this on top of my image. Maybe you don't want them to scribble on top of your image. Maybe you want them to just focus on keyboard presses. Alternatively, maybe you want to like uphold your theme better instead of just a pointer. Maybe you want, crosshairs. Maybe you want to just have like a transparent PNG as like a cursor, right? So you can upload your own custom pointer. The really cool thing about a custom image pointer is you could always constantly be changing that. So if you're hovering over one area, maybe it's, the top of your window could just be like a panel of options, and as soon as you point your mouse pointer up towards those options over that panel, all of a sudden maybe your cursor changes to something else. So pretty simple, but also really helps to like build up a project. And then the only other thing that I'm wanting to show you guys is, I know I've been talking a little bit about how to go on to processing.org and find examples. You also have the ability right in processing to find examples. And so, especially if you guys have already coded before, you're going to want to start diving into this example stuff sooner than later, and start harvesting, kind of new territory to be dropping into your code. But all these examples, they literally open an entire processing sketch, like a saved sketch, that you could play and see what it's doing. And if you're like, oh yeah, this is the same kind of component that I want to be using, then you could literally look in their coded sketch, find out how it's working, copy and paste the bits of code you need, right? So it's really powerful to be able to have the ability to just check out sketches right there. And also, as I mentioned toward the beginning of the lecture here, the different components that change color in processing, like integers, this p image, like what is a p image? Well, if you right click on that, you'll have an option for find in reference. It'll literally bring you right to the processing website and give you information on what a p image is and how to use it. So you literally could use that as a guide to then use inject your own image. So there's a variety of ways that realistically, like this program ends up being this project ends up being a really good way for you guys to get a little bit more like empowered and more comfortable with kind of finding your own ways of navigating the project. And I mean, like UB is this like research institution, so it pairs well with that mentality of like, okay, I know I got to do this image. How do I do it again? I don't remember. Right on the website, there's some options, right? So we're right at about time, I think. I think we're doing pretty good. At about 1 hour now. My throat's still kind of scratchy, so that's not good. I'm hoping it's just dry in here. Let me just double check our schedule. I think that's all we were doing today is the lecture and then this exercise. Does anybody have questions before we start this exercise? If you want to run to the bathroom or whatever real quick, but does anybody have questions on storyboarding? I think that's something, we didn't really talk about that in class, unfortunately. I was going to have it all due already by today, but because we didn't talk about it, I wanted to leave another day for it. So,
how many frames do you want us to do for the storyboard?
It all depends on your project. So if your project's going to be like these different scenes, and each of these different scenes has different things we click on, you're probably going to want to have a different, sketched out window of each of those different scenes, and like arrows to different content, and like what that's going to do, or what sound effect, or you know what I mean. So it's number one, it's for us to see like what you're doing or what you're hoping to do. But number two, it also is then like a roadmap, right? You already know where things are going to be, and you can start to execute them. Whereas if you just do like one drawing and you try to pass that off as a storyboard, it's not going to work for you, and you're going to have trouble like figuring out, what you need to add, why this seems bland and everybody else's might seem like they're really advanced or something. It's really just making sure it's organized. So in general, probably like 2 or 3 different pages of like little, different thumbnails, if that makes sense. Yeah. You don't need to color it. It's just making sure you also, because you'll be uploading these sketches like we've done before. So the one big key point here is, I probably wouldn't go smaller than like 4 rectangle like frames per page. That way, and also like outline them in pen, Sharpie, right? Like fine point Sharpie, so that when you upload them, have some clear writing, right? Since we're not in person, it's a little bit harder to translate through the web. Being able to deliver what you're doing to everybody else will allow them to then better think of comments or questions to probe you with to get you onto like a finalized concept. So, anybody else have questions? I am so surprised everybody's so quiet, and nobody's even used the chat yet. That's peculiar. Give me 1 second. Just trying to keep up with who's all here. Not so much for attendance. I mean, I'm still upholding attendance, but as we get into coding, I got to really make sure I'm checking in with people who are sick or whatever. Try to keep them up to date. I'm sure that a few of us might have already started getting sick. Who really knows? I haven't heard of anything from anybody, so I'm assuming everybody's healthy. But just trying to think that's everybody. I'm missing one person, but anyway. Oh, yeah. Okay. So hopefully everybody's got processing installed. What you're going to want to do is open up this website, and I wouldn't say use it like have it on screen all the time, because I'm going to be walking you guys through it. But if you miss something, you go back and look. You will be copying code from here as well. So what I like to do, again, this is what I mentioned in my workflows a lot, is if you're on a Mac, you have the option, like the F3 button. If you press that, you should have like that expose key, or shows you your other windows. So as you're working back and forth, that's one way to quickly switch back to another window, especially now that we're all, working remotely. So the first thing we're going to need is this this exercise 3 audio files right here. So we want to just go ahead and click that. That'll download. So then we're kind of just going step by step here. So I hope everybody is on point here. All we're going to do is launch processing. So get that open. And then we are going to install a tool to processing. And this tool will allow us to manipulate audio. And there's other tools that you can install that could be beneficial. There's actually other audio tools as well. But I've been using Minim. It works fine. It's the same workflow. I don't have to redesign my course. It's all just the same. So once you have processing open, we're just following the directions. We're going to go up to Tools and Add Tool. So in processing, Tool, Tools panel, and then Add Tool. And at the top here, there's a tab for libraries. We're going to tap on libraries, and what we're going to actually do is install this Minim. So we're going to go to click on the filter and just do a search for Minim, M-I-N-I-M, Minim. And mine's already downloaded, so it'll have a green check mark. But if you need to download it, you just click on it and hit install in the bottom right. Once that is installed, what you're going to want to do is just completely quit processing and then reopen it. Because most of the time, some of the time at least, it doesn't correctly load in until you launch it again. And by completely quitting, some people don't grasp this, I guess. Not just closing these windows, because just closing, if I close both these windows, processing's still open. It's just no windows are open. So you literally have to go to quit processing, right? Make sure it's completely gone. In my dock, there'll be no little dot next to processing. So that's the first step, making sure we have that that library installed of Minute, and we actually never have to install that again. As long as we're working on the same machine, we won't have to worry about it. Okay. So while we're in processing, let's go up to File and Save As. Okay. And click your little drop-down arrow of where to save this. We'll save it right on your desktop for right now. But actually, let's create a new folder. And we'll call this Processing Exercise 1. Because we will have a second part, and you want to make sure you remember which is which. So this is Processing Exercise 1. Create a folder for that. And then the name, we also are going to call this Processing Exercise 1. Okay. Save. I think somebody just joined. Did somebody join? I heard a beep. Oh, maybe somebody's turning a microphone on or off. Anyway. Okay. And then the next thing to note is that to be using different files with our program, with processing, they need to be in the same folder as your project is in. So I'm going to minimize this just to make it easier. I'm going to show you guys real briefly what I'm talking about. So here's my folder 1, right? Processing exercise 1. And processing itself always, why do I have 2 folders? That's funky. I don't know if you guys have 2 folders, but we should only have 1 folder. Okay, my mistake. Maybe it already saved a folder. Anyway, so we have processing exercise folder. Inside of that, we should have the processing file, right? There's nothing else in there. Our audio files are not in there. So this is what I want you guys to do. If we navigate to where our downloads are, we have the exercise 4 audio files zip. We'll double click that zip to extract the files, right? We have all of these 4 files. Instead of dragging them into the other folder, what I want you guys to do is highlight all of these and drag them into your processing window. And so when you let go, it's going to tell you have 4 things added. And why isn't it popping up? That's peculiar. Save. Oh, it renamed my folder. Geez, okay. Sorry for this. I'm actually kind of lost as to why this has seemed like it's changed, other than the fact that maybe I'm missing something. I think one of the problems that I forgot to mention, which is probably on this tutorial here. Oh, yeah. Only lowercase letters and spaces can be used for your processing file. My mistake. I'll make sure to correct that for the next class. So what ended up happening was processing saved a new version. So somewhere on your desktop, you probably have a new folder. If you open that folder up, you should see this new exercise folder. So sorry, this is a little all over the place. But what I'm getting at here is when you drag those audio files into processing, what's interesting is processing automatically creates a new folder called data that's right next to your PDE file. So if you open the data folder, there's all of that new content that we just dragged in. So you could manually create your own folder called data and then put it in there. You could have all of the audio files right next to the PDE, but it just is really sloppy and it's hard to know where the PDE, like the processing file is. So this is really what you guys should have. Processing.
Tell us how to do that again. Pulling the 4 files out of what we downloaded.
Yeah. So here, I'm just gonna start over. So if I quit that, if I do, oops, we'll kind of start fresh so there's no confusion. So if I go to new file with processing, I go to save as, and I'm gonna delete that as well. Oh, okay. So it's gonna save us a sketch folder already, so we don't have to make a new folder. That was the other confusion. It's all coming back. Processing underscore exercise underscore 1 on my desktop. save. Boom, creates a folder, processing exercise 1, right? And we open that, it's only going to show that PDE file, which is our processing file. So to your other point, how do you move stuff in? Well, I just went to my downloads. I double-clicked the zip file, which gives me a folder of audio. And I just grabbed all those individual audio files and dragged and dropped them right into my processing window and let go. So now if I go back and I look like, oh, okay, now what's in my processing exercise 1 folder, it automatically will create that data folder. Okay. Sorry for the slight confusion. It's goofy just because we're working with like a data folder instead of a project file, I realize, but this is still way more simplified than a lot of coding can be. Essentially, we just have our file and then our other files that we're using, like audio. Later we'll add photos, images. There is a way to use some video clips if you wanted to add a short video clip. Okay. So, okay. Hopefully everybody is on par. Can we use raster and vector images in our project? Yes. You can basically just do all images if you really wanted to. Some people like to just have a very structured process, which the tutorial we go over on next Monday will be more along that scene-based structure. Everything's well organized out. However, I really urge a lot of you to also be thinking experimentally. I wish I had a tutorial to walk through some of that. I get into it a little bit next week, but basically just making bizarre things change and update and messing around with code. In that regard, when you're doing that kind of exploration, all of that stuff is vectors, so that also suffices the need. You don't have to use images. It just ends up being a lot of people default to that because they think it's easier way. It really just depends on preferences. If you want to be playful, you don't really even need images. So yes, vector or raster. Okay, moving on here. So on the website for this tutorial, we're actually going to copy and paste a chunk of code. And I put this all in orange, so it's a little tricky to read, but the main point here is that we want to select everything that's in part 5 here, highlight that, and then we're going to paste it. So only the orange bit, right? And we want everything from top to bottom. So I'm going to copy that. I'm going to go back to processing and paste. Okay. And if we hit play, we should be able to hear audio playing. We should hear this door knocking, kind of somebody walking across the room, like turning a doorknob. Right? So that's where we should be at. And again, I'm just going to kind of slightly go slow, anticipating people take a little bit of time to get here. But if I get too far ahead or you have questions, throw your mic on and ask. So if you go ahead and close that preview window, we're going to take a look and see what's going on here, because the most important thing is not that we just copy and paste stuff. That isn't going to get us through the semester here. What we really need to do is okay, what is this bit of code that we are harvesting, and how are we harvesting it? And once we understand that, then we can then start to be constructing our own projects. So if we scroll to the top, right, line 1, and if you don't have line 1 popped up, I think everybody should. I copy and paste my code, the packet DFF does not exist. Probably didn't install minim that we went over, or you didn't restart processing after you installed minim. That is my only suggestion. So what you'd have to do is, I would do like Command Option Escape and just force quit processing. Like make sure processing is actually closed after you install it, after you install that library, and then you should be good. Because the only library that we're using here that's not already in processing is that minim. So that's the only thing I can think of. So you just want to revisit those past steps. Okay, I'm just going to kind of keep rambling on this. So as you can see here, I guess this wasn't in my lecture, so I'll kind of reiterate here now. You see this first line is in gray. It's like grayed out, right? It's like a darker gray, but it's still gray. That's because we have these two slashes. Putting two forward slashes turns that line into a comment. And comments do not get executed by the program, so processing basically ignores those lines. If we were to delete it, it turns to black. It's thinking import is something. It's giving us an error because it's wrong, right? Like that wouldn't be logical code. So we'll just leave it commented out. Okay, so that's line 1. We're just gonna go kind of like line by line, make sure we understand what's going on. And again, holler if you have questions. So as I noted right here with this comment, import of the minim library and declaring special audio player variables. So that's everything happening here, right? And I can kind of like put a couple spaces if I want. Well, maybe I won't add spaces just so we are all on the same lines for right now. So lines 2 and 3, these two lines are utilized with minim. It basically, for your purposes, again, you're not memorizing this, these two lines. All you need to do is next time you're doing your own code, you copy this and you paste it in the top of your program, and then your program will also know that it's going to access the minim library. That's about the extent of that. From there on, anytime you are going to want to load in a new audio file, you'll have to declare it. So just like if we're going to declare an integer, right? Like integer emergency, right? How we went over that example. This is how we are declaring an audio file. And this audio player is the syntax we need to use to say, okay, we're going to create a new audio file. Although it doesn't highlight a different color because it is a different library. And the audio file is going to be player 1. The next audio file is going to be called player 2. And the third one is going to be called player 3. Okay? However, just to note here, our audio files in our folder, in our data folder, are not called player 1, player 2, player 3. So how does processing know to play those particular files? Well, that's where we get down here to, I don't even know what this is, audio input? Input? To be honest, you could delete that. I don't even know why that's in there, to be honest. Audio input. It's probably going to be like if you wanted to utilize a microphone maybe, but we don't need that. So line 7 you could delete if that helps you to not be confused. Okay, so back to that question. How does processing know what player 1 is playing from, what it's loading from? So we'd have to come down here and start to look in setup, because setup is everything that's loaded into the program. So if we want to play audio, we want to load an image, we want to declare the size of the canvas, we need to tell processing that information, and all of that's going to happen inside setup. And what do I mean by inside setup? Inside these brackets. So you see I click at the starting bracket of setup here, and it highlights my ending bracket. And you notice how I have a comment that's saying ends void setup. That comment is something I wrote. So when you guys are coding, that's something you should write as well. If you don't use this kind of structure of using comments to like notate where things are stopping and ending, you will lose track of your code. It will break and you won't know what's going on. And it'll just be me coming in and saying, oh, you have too many brackets in there that aren't being used or what have you. So the biggest thing is when you have too many brackets or you're missing a bracket, I don't want you guys to do this. I'm going to show you. But if I deleted that bracket and I hit play, it'll literally telling me that, hey, we found a starting bracket, but you are missing a matching end bracket. So you'll get an error like that. Or, you know, if I add an extra bracket down here and I try to hit play, it'll give you some weird thing. And, you know, that error doesn't really even make sense. And it'll underline your error in red, basically meaning like if I click here on this end bracket that I just made up, it doesn't highlight any starting bracket, meaning it's probably extra or I messed up somewhere else, right? So most of the time processing is pretty good for telling you exactly where you're having problems. And that's why I like to use it as an intro course. I'm hopefully actually going to be transitioning to P5JS at some point because the department wants to do that route. But okay, getting back on track. So declaring audio, right? Well, inside our void setup, line 10, that's obviously we're just declaring our canvas size. And as we played it, you can see that it's 640 by 480, kind of a smaller size on the page. That's fine. And then we have a note in here that's saying the variable minim is called each time a new sound is required into the sketch. So that's kind of correct, but it's also a little goofy. Essentially, because I changed this recently and I forgot to update that comment. That's kind of referring to line 12, where you're saying minim equals new minim this. Also, something you don't have to memorize. This is called once before we can load our audio files, right? That's really the comment we should have. So again, if you were going to save this as your own example file to reference later, you could always put in your own comments in here, right? Rather than writing notes on a page, you could put 2 slashes anywhere and take a comment for yourself that makes sense. Okay. So line 12 is again needed by the program, but then lines 13, 14, and 15, this is actually where we're loading these files. So what is player 1? Well, as of this line, processing knows player 1 is an audio file, right? We declared it up here on line 4, right? Audio player 1 is here, and this next bit of code is also something like syntax-wise required by the program. But then in parentheses, with quotes, this is the exact name of the exact file, right? So we can, to kind of like get around confusion when you guys go to add your own audio files, number one, I always recommend that they're short, right? They're not too long. But also what I usually say is like, you could just go in there and Command C, copy that entire thing, and then come into your program, Command paste. That way you know you're pasting the exact same name. Because if you type something wrong, right? If I put .aif and I didn't spell it right, when I hit play, I'm gonna get an error. It's gonna say null pointer exception. Null pointer is always going to mean the program cannot point to the file that you're trying to link. Null pointer exception. And it literally kind of gives me an error message here. It says, couldn't load the file knock walk door open.aif. So I hit stop to get rid of that window. It can't load it. It doesn't give you an error what's wrong. You just have to then realize, like, you go back to your file and you're like, oh, it's the wrong spelling or the wrong syntax, right? You might have a capital F, and that would also be wrong. So it's always good to make sure you're, maybe just copy and paste stuff. But I think we had Peyton joined. I don't know if anybody else joined. So yeah, Peyton, we're just doing exercise 1. It's right on the website on our schedule day as well. You'll just need to have processing open, and then you can start following the steps and on the exercise page, and then we're just going along here. Okay, does anybody have questions on audio like so far? So we declare some essential syntax for the library. We're declaring that there's going to be audio files with their names, right? That's step 2. We're declaring an audio file, and we're declaring the name. And then we're using that declared name to then load a file with a particular name, right? Once we do that, the file is now accessible to our use in our sketch. So right here, player1.loop is literally the syntax for like looping that file, playing it over and over. Somebody have a question? Okay. I'm assuming everybody's kind of up to par. I think we're a little bit below par on time, so I'm trying not to go too fast. So when we hit play, like hit run up here, that's literally just going to play our sketch, right? It's just looping draw over and over. So we're hearing audio, but actually that audio is being looped within setup, right? We're actually telling it to loop within setup. I don't need you guys to do this, but if I were to copy this out and paste that loop in draw and play this, we won't really hear anything. And I usually ask the question why, but it's kind of weird to do over line. The reason we wouldn't hear anything right there is because every 60 times a second in draw, we're starting to loop the audio from the beginning. So it's never going to play out. It's always going to keep starting at the beginning. So, for instance, we also could do a syntax called, audio file called player1.play, and that would also work. But then when we hit play, if we're playing this within draw, it's actually sounding correctly right now. Oh no, there it goes. Okay, that's why. I forgot. If you have something that plays in draw like this, it'll go through to the end of the track, and then it'll stop there, and it won't start at the beginning, and you'll hear like this juddering noise at the end. So when we think about playing audio in processing, we have to do it in places that make sense. Most of the time that's going to be not in draw because draw is continuously looping, right? So it'll be in instances like a mouse press, because a mouse press is a single one-time event, where you press it, it could play something. And then if you press it again, it could play it again. So I'm just going to leave that player1.loop where it was. So if you want to put that back, we can continue the next step. The next thing I mentioned was you could use colorpicker.com. It's a website that allows you to like, find a particular color that you want. You could use any kind of programs. What I also like to do is show you guys, for you that have a Mac computer, there's a utility on your machine called Digital Color Meter. And this is actually under the Finder. So if you were to go to Finder and you go to Go at the top, you go to Utilities, Digital Color Multimeter is right there. If you double click it, you open it up. This just allows you to like point to individual pixels, and you can get the RGB values for that particular color. So if you have something on screen and you don't know what color value it is and you really want that color, this could be a quick way as well, right? You're just pointing like, oh, I want that purple. So in my case, if I want this purple, I just write down the RGB values, 138, 106, 190. Okay, so all this step is I'm want you guys to change the background color. So getting in here, 138, comma, 106, comma, 190. You can put any colors you want. Just showing us that we can update this background to be, whatever color we want. All right, now we're starting to get, we're going to start to get into a little bit more nitty-gritty stuff here. So again, I haven't heard questions, so I'm assuming everybody is on point. So we're on step 7. We're going to place this one line of code just above the setup block as it's declaring the variable x. We're going to be using it for timing and the position and size of items in the void draw loop. So before we can use an integer, we have to declare it. So that's all that we're saying. So if we go back to our code, and actually, I'm going to see if I could do this real quick. Yes. How about that? Does that work? Oh, it will, but then when I play something, it's gonna go over. Anyway, okay, that's fine. Okay, so I copied line 7, and that's literally just going anywhere above setup. So this is void setup, literally anywhere up here. You could like return any lines down. It doesn't really matter where you put it. I like to usually have all of my integers kind of isolated with a blank line, right? In space, like these blank lines in processing, don't matter at all. It's just for your visual comprehension, using space. So paste that in up there, and then we're going to copy this content from step 8, and we're going to place this next code after the background color within the void draw block. So this brings us to our vital point here, is that, well, background's right here, right? So we could just paste it down here. No, we want to paste it within the void draw block, meaning draw is ending right here, right? We have a comment even that's saying this is where it's ending because I put the comment there. So we want to return some lines down, right? Something like that, and then we could paste it in there, right? So the next point I want to bring up is, you notice when we paste this, everything's kind of like hugging the left side, kind of weird. Actually, no, it kind of looks right. The one thing we could do right now, though, to see if it actually helps, is this is what you guys will be using a lot, is Command T. It's auto format. So as you're going through and like things look kind of sloppy, you could always hit Command T, And it should organize everything logically within the order, the hierarchy of the code, right? So everything that's in a sublayer is tabbed over. So for instance, this is our void draw. I'm going to return that down a couple lines. So see how everything kind of has spaces now? What was I going to say? Oh, inside of our void draw, everything is tabbed over, right? And then we have more brackets here for our if conditional. And the content within those brackets of the if conditional is also tabbed over. See that? So it's a way of kind of visually seeing what content is in within what element or what sections of your code. Okay, so let's go ahead and play this and see what's going on. And we should have this oval kind of like expanding across the screen while our audio is playing, right? This ellipse. And so at some point it's also going back to the beginning. Why is it going back to the beginning? Well, that's the point we're going to make here. So if we go back to our code and we take a look here at this new section that we just pasted in, we're going to see that the first thing we're doing is we're doing some kind of math right here. We're saying x is equal to x plus 1. Well, what is x, right? X is literally this integer that we created at the beginning. We already named x. X is a name. What does x mean? It means nothing right now until we start to use it, which is what we're doing here on line 27. So the big problem is, okay, if we're doing math, we're adding 1 to it. What is the value of x? Right? That's not something I mentioned in the lecture. Right here, we did define it at the top into x, but we didn't set any initial value. Therefore, if we don't have an initial value, an integer is always going to be the value of 0. So we could literally put like equals 0 right there if we wanted to for our own sanity. But in the end, it really is going to be 0 no matter what when the program starts. And then once we get down to start looping this background of draw, we're going to have the first time this is read by our program, it's going to be 0, right? Because x is 0, equals 0 plus 1. Well, what's 0 plus 1? 1, right? The value would be 1. So then down here, you'll see we're drawing an ellipse. And where is the ellipse that we're drawing it? Well, it's at the location x and 50. X being the x-axis, right? Because the first value is the x location, the second value is the y location, and then this is the scale, right? So we're using it to kind of change the scale. We're also using it to like where it's located. And then because every single time we're playing this, draw is consecutively, remember, it's looping, right? So the next time processing, like the second frame that this is running, the value of x is now not going to be 0 anymore. It's going to be 1. So 1 plus 1 is 2, right? So down here, the value of x is now going to be 2. Right? Anywhere we're using that integer, the name of that integer, it's going to be updated that new value. So this is where the programming starts to get really interesting, and we're able to start evolving what's happening. So this could be, really whatever we want, but for right now, we're going to keep continuing the tutorial just for sake of time, because we only have a couple minutes left. Go ahead and save your processing. I'm going to Command S. Okay. And then we're going to declare 2 more variables. So copy lines, step 10. We're going to paste these up here at the top as well. And these are going to be, you can paste them right after, the X. Okay? So similarly, just like we did before, we're going to copy everything that we have in step 11. And we're going to paste it, like it says, below the code, or paste below the code beneath the background function in the draw loop before the closing bracket. So just like we did before, I'm going to paste it in here, and I'm still going to have that last bracket down there, and everything that I just pasted is kind of right above our ending bracket for draw. Right? So now, that'll probably take you a second if you're not caught up. Once you get that pasted in, go ahead and play it, and we can take a look at the new changes. Okay, so we have another shape moving. It's blinking. Okay, let's go back and look at the code. The one thing that, I guess this is, sorry if I'm not trying to be confusing. The one thing I didn't cover here is back where we have this x equals x plus 1, right underneath that, we have that condition. We didn't cover like what that condition's doing. So let's just look at that real quick. So if the value of x, right, which is always changing, as we can see right above it, it's always updating. If it ever gets higher than 640, which it will, right, after some time, it'll keep adding until it's over that, which if we wanted to be in a specific seconds, we could basically just define like, 60 frames is 1 second. So, if you want it to be 3 seconds, that's 180, right? So if our x is greater than that, we're going to do something. Whatever we're going to do is between the starting bracket and the ending bracket of that condition. So this is always something that it's a little tricky for people to grasp who are new to coding. So it probably will take you a couple of times to like look at this. And that's why I'm stopping to revisit it right now again, is that the thing that we're doing here, right, if x is greater than 640, what are we going to do? We're going to set the value of x to equal 0. So we're setting it back to beginning to where it started with, right? So that's why that original shape, if we play this, that original shape, once it hits 640, the value goes back to 0 and it starts off from the beginning again. That's why it looks like it's resetting, because it literally is resetting. Okay. Similar kind of components with the z. We're still adding to itself. If z is greater than a certain number, we're setting it to 0. All the same kind of stuff. In this instance, for the fill and the ellipse, we're kind of using two different things. One, we're using the fill color of that second shape based on the location. So as that's moving over time, it's changing a value, right? That z is changing a value. So if we multiply that value, we get a different color. That's why the color looks like it's changing. And then we're actually using the x value here. So anytime you declare integer values, you could use them anywhere, right? Anywhere you have a number, you could always do some math. So this is kind of a side tangent, but you could be putting the stuff in parentheses, or if that helps you, right? Like a logical operation. Oh, this is going to be this. Like for instance, if I did, if I wanted to expand on this math right here, if I wanted to say 2 times 600 minus x, well, right now it would be, the first thing it would be doing is 2 times 600, and then whatever the value of that is would be minusing x. Well, maybe when we want to do the 600 minus x first, right? And then the value of that is then multiplied by 2. So it's just logical operations, just like any kind of math. And if we play that, it's going to be very similar. Or it's not, it's going to break it. There it is. Oh, I started it off too far over is all. Okay. So just kind of going through a couple different options here. So the step 12, we're going to cut the background from our draw. So right here we have the whole line that's called background with some numbers. We're going to select the entire thing, including the semicolon. You're going to hit Command X, which is going to be cutting it, like copying and deleting. And let's paste that within the setup, right? So before setup ends. So somewhere up here, we'll paste our background. So now if we play this with our background in setup, our background is never refreshing because it's not in draw, continually drawing the background over. So we get these streaky effect lines because we're seeing like the outlines of that shape being drawn but never being drawn over top of, right? So it's kind of thinking through like how do you want your visual to be unfolding to us. It's kind of like different tricks that you can play. So the last bit I think that we have time for today, which is pretty much to the end. So maybe even before you guys leave, you want to just finish this, unless you have like another class to get to or something. But we only have 2 more steps. So otherwise, if you have to run, maybe just make sure you finish this last couple things on your own. Yeah, just make sure you have, as I mentioned, if you came late, make sure you have all of your storyboarding kind of sketches, easy to read, outlined in black marker, in rectangles, so we could tell like what's in your scene. Take photos of that, put in the Google Drive. On Wednesday, we're going to do our best to have like some social talk on the projects. All right, so I'm just going to go over these last 2 things real quick. Step 13, we're going to copy this bit. And I literally gave you guys an image of like where you should paste this because it is a little tricky. So as you can see, we're inside the void draw, right? But we're going to be placing it within this Z condition before the end of that Z condition ends. So you see if Z is greater than 120, it has a starting bracket and an ending bracket. We want to put it before the ending bracket. So here's my if Z ends. I'm going to return that down, paste it. Command T if you want it to look clean, right? So this is what I pasted. So I even gave a note here, a comment. When the condition Z is true, meaning if Z is greater than 120, right? That would mean it's true. Then Z would do something. Player 2, which is an audio file we loaded, right? Plays its sound starting at 100 milliseconds into the file, right? So this is all we're doing right here is we're kind of, you could think of audio as, I should have said this earlier, but you could think of audio when you're playing it as like a cassette tape. Once it plays the end, it won't know to start at the beginning again unless you rewind it. So this is just preemptively saying, okay, make sure before you play every time you're going to rewind. And then it's also going to reset the background. So anytime Z is greater than 120, we're going to rewind the audio and play it. So if you play that, we should be able to hear that effect. Right? And we should see that we're getting that black to flash because every 120 seconds when we're playing that yo, like player 2 sound effect, we also said to draw a black background, right? Otherwise, if we took that out, it wouldn't put the black background. But let me see if I could put another thing in here saying 15. That's too dark. I'm just trying to see if opacity would work here. Nope, I'd have to revisit opacity apparently. Okay, and then we just have one more. I'll get through this one more point, and then if anybody had questions before you leave. So you want to make sure you're getting everything that's going on here. So last step is step 14. Paste this code somewhere within the within draw to generate one additional ellipse. And it doesn't matter where, so just even right at the top of draw, we just paste this. Command T to organize it and play. So as you can see here, this shape is way more dynamic, right? It's still updating when we have that sound effect happen, right? So it's kind of the same timing as that second shape. But if we go back to look at the code, at this point we should be able to tell why and like what's happening, right? It's only these 3 lines of code. So we're drawing something at y. What's the value of y? Well, y is scaling upwards like it is because we're using a different variable that's also gaining, right? Z is also adding to itself down there. So why not use Z to factor in to equal another value of another variable? So we have all this versatility going on. It goes back to that point where wherever you have an integer, or wherever you have a number, you could use an integer instead. So then the colors were changing. So that's about the whole tutorial. And then after this point, and usually in class, like everything went well, we'd have time to play around. So if you guys don't have another class, I'll stick around for a couple minutes if anybody has questions. But also, you want to make sure that you are playing around a little bit and seeing like, oh, can you do this differently with this different shape, or have an audio effect do something differently. So it's starting to like probe around a little bit and see what's happening. And if you run into problems and I'm not here and you're still playing around, again, what you could always do is right click on any one of these functions, find in reference, right? And it'll bring open a page and it'll tell you exactly like what you can be doing with that. So I definitely, since we had a week off too, I definitely take 15 minutes or so and play around with a couple options and make sure you understand this. And while things are fresh, go in and put your own comments in, what things are doing and why or how. That way when you save it again, right? Like right now I'm going to save again. You'll have this for reference later. So if you forget like, oh, how did I, do the audio player? We have this reference now. Okay. So yeah, if anybody has questions.